We present a novel method of finding an optimal set of projections of high-dimensional data. In order to visually explore high-dimensional datasets, users are interested in a small set of projections that provides relevant data patterns. The number of possible projections grows non-linearly with the number of data dimensions. Related work either does not take the data relations into account, or it provides a large set of projections that grows quadratically with a number of dimensions n. A PCA-based set of projections is presented, which has too many projections for being applicable. Our approach guarantees a small set of n half optimal projections. Here you can see the set of projections provided by our approach. Here the number of projections grows linearly in n. Our main idea is to discard affine transformations. What exactly does that mean? As seen, P1 and P2 are considered similar, because a simple affine transformation of P1 leads to P2. In contrast, P3 cannot be obtained by an affine map of P1 and P2, thus it shows novel information. For the same reasons, P4 gives new information with respect to P1 and P3. In order to find this set of projections, we introduce a simple distance measure. The larger the distance between projections, the more information is provided. Based on the distance measure, we present an algorithm to find a finite number of projections that represent the high-dimensional data best. This algorithm is based upon the idea that these projections have a large distance to each other. For further information on the distance, please see the paper. We present the optimal set of projections on 4 real benchmark datasets. Therein, it is illustrated how consecutive projections can be turned into a tour in which every subsequent projection yields novel data insights. This presents an intuitive way to explore the characteristics and the general relations of the data. It is evident that relevant data structures are presented in early stages of the tour. Our algorithm is parameterized by a user-defined start projection. It influences the final outcome. However, important data structures are still visited, as you can see here. Even though the sets vary with the initial projection, the tool facilitates a very similar insight into the data and the relevant data patterns too. We show an approach for an interactive analysis of a dataset by smoothly changing the projection matrix. During the interaction, our approach allows to maximize or minimize the distance between the current and the updated projection. We compare our method to a projection tour created with principal component analysis, which is a standard approach in visual data exploration. A PCA tour grows quadratically with the data dimensionality, and thus produces a lot of redundant views. Compared to that, our approach only shows each pattern once. In total, both approaches provide the relevant data patterns, but our approach requires fewer projections.